then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing.
Greetings, Precalculus students, and welcome to lesson number 5, week number 2. Let's get into it. So today's lesson is on range of functions. Last lesson we looked at domain of functions from a graphical standpoint. Today we're going to look at range of functions from a graphical standpoint. On today's agenda, we're going to look at evaluating functions graphically, and then we're going to look at finding the range of functions graphically. Okay, so we're looking at evaluating functions from graphs. And so you see there a graph in blue. So that's the graph of f of x. And so what we'll do is we'll evaluate this graph at different values. So let's say, for instance, we want to find f of 1. So to find f of 1 using the graph, we'll find 1 on the x-axis, go to where it touches the graph, and find a corresponding y value. That's our answer. So f of 1 is 2. Let's try another value. Let's say we find f of 5. So we'll find 5 on the x-axis, find the graph, touch the graph, the corresponding y value is our answer. So f of 5 is -3. We'll look at one more. So we'll find f of 0. So I'm gonna give you a moment to look at f of 0, see what f of 0 should be. Again, find 0 on the x-axis, go to the graph and find a corresponding y value. And of course, you should have got that f of 0 is 3. So that's evaluating functions from graphs. Okay, the last thing we're going to do is look at range of functions. So this says domain and range. It's the same presentation that was used for domain, except in this case, we're going to be looking at all the range of the functions. So again, as I said before, we know for domain, we're looking at the x-axis, left endpoint for right to right endpoint. For range, what we're looking at today, we're concentrating on the y-axis, and we're looking from bottom endpoint to top endpoint. So again, we're going to see the same graphs we use for domain, but now we're looking at range. So again, when I'm finding the range of a graph of a function, I just try to find its bottom endpoint and its top endpoint and go from there. So hopefully you can see that the bottom point of this graph is -3 and it's closed, so there'll be a bracket on it. And the top of this graph is 6. And again, it's closed, and by closed, it doesn't have to be a closed circle. Just to be a regular line or curve is closed. Only thing that's not considered closed, of course, is an open circle. So we should have brackets, and we're going from -3 to 6. It was that simple. Sometimes when people look at range, a mistake that's often occurs, they look at these horizontal endpoints. And they think, range is y, but I have to look at these horizontal endpoints. So some people would say the range would incorrectly say that the range was -3 to -1. But we're not moving from horizontal endpoints. We're going from the bottom endpoint, so the very lowest point, to the top endpoint point, to the very top point. And those points could have closed or open circles on them, or they could not. It really doesn't matter whether they have circles on them or not. Bottom endpoint to top endpoint. Let's look at the next graph. So there's the next graph. And again, when you think of range, you're thinking of y. So our bottom endpoint here is -4. Our top endpoint is 6. There are open circles on both of those, so we'll have parentheses instead of brackets, of course. Let's look at our next graph. So our next graph, again, we're just looking at the bottom endpoint. So the bottom endpoint is 3. This is the lowest point of the graph. The top endpoint is 8. So we're going from 3 to 8 with brackets. Again, if you don't see an open circle, it's understood to be closed or included. Next graph. So again, a mistake some people would make is they would say, okay, it's Y, but they would look at starting from here and say that it's -3 to 3. That, of course, is incorrect. We find the lowest point, not where a circle is, but the lowest point. So the lowest point is actually -6 to 3. So we're going from -6 to 3. Notice -6 is closed, but the 3 is open. So should be a bracket on a -6, parenthesis on the 3. Let's look at our next graph. So again, this is a line, and it's going and it's going to keep going down. So it's going all the way down to -infinity, and it's also going to keep going all the way up. So it's going all the way up to infinity. So the range, of course, is -infinity to infinity. Let's look at the next graph. Now this range is not -infinity to infinity. The domain is, but not the range. So it does have a stopping point. And if you see at the bottom, the lowest point is 2. So there's nothing below 2. So it's not like I'm going from -infinity to anywhere. I'm going from 2 to somewhere. And there's a bracket on that 2, of course. But you see, there is no stopping point at the top. It keeps going all the way up to infinity. So then this range is 2 with a bracket on the 2 to infinity. Next graph. So we have 2 graphs remaining. Again, this should start to make a little more sense. So there's the bottom point, bracket 1, no stopping point. So bracket 1 to infinity. And our last one, so this is going all the way down. So there's no bottom point. So it's starting from -infinity, but there is a stopping point at the top. It's stopping at 3 with a bracket. So -infinity to 3 with the bracket is the range for that one. Okay, that concludes lesson number 5. We'll see you next time.